Okay, so now that we've finished getting the derivative, we need to evaluate this to find the gradient of the tangent to that function. Now, before I had said that we're going to evaluate it at x equals 1. However, when I looked at the denominator, I realized, well, the denominator can never be 0. And if x equaled 1, we would have the square root of 1 minus 2, which would be the square root of negative 1. And so, being that it's a square root function, that square root function inside there can never be less than 0. And because it's in the denominator, that denominator can never be less than or equal to 0, which means that x has to be greater than 2, not just greater than or equal to, it has to be greater than 2. Therefore, I've chosen to change this to 3, so that at least the denominator will be valid and we won't get an undefined function at that point. Okay, so let's now look at this here as the the gradient. M is dy by dx evaluated at x equals 3. And I think there goes my hopes of doing all this in mental math form, because I'm not sure exactly what 27 times 12 is off the top of my head. So along here we'll just substitute in 3 everywhere we're seeing x. And put that over 3 minus 2. Okay, so I'll try to simplify this a little bit. So of course there's 12 times 27 minus 5. And then here is the square root of 1. I can do that in my head, luckily. And then we've got 3 to the power 4, which is 81, so 3 times 81, which I know is 243, minus 15 plus 2. And then here we've got 3 minus 2 which is 1. And the reciprocal of that, the square root. And then over here we've got 1. Okay, so I can reduce down a little bit of this, simplify a little, and I'll probably need a calculator for some of this. So 324 minus 5 is 319, and the square root of 1 is just 1, minus a half times, so we've got 243 minus 13, which is 230. Actually, we don't need that over 1 anymore. And half of 230 is 115, so we'll do 3 times, 319 minus 115, which will give us 204. So the gradient of the tangent to this function at x equals 3 is 204. So what I'm going to do here is I have graphed this on the TI-84, and this little marking right there is 2. There's a vertical asymptote at 2, and then I think this minimum there, I believe, if I'm not mistaken, is around, let me go the other way here. There we go, there's the cursor. So I'm going to find out what that y value is. It's around 135 or so. So let me just calculate the minimum. So the left bound is where the cursor is. The right bound, I'll go over to the right side of the minimum. I'm not going to guess. And it looks like the minimum is when x is at 2.25, 2.26, y is 135.245-ish. So that minimum is well above the x-axis. Now if we wanted to quickly take a look at the table of values, second graph gives us the table of values, we see that when x is 0, 1, or 2, it gives us errors, which means that the function is undefined. And then when x equals 3, y is 230, 4, y is 530.33, etc. So it keeps increasing from there. Okay, so we can scroll through to see the values of points along the way on the curve. And if I just go to the left of 2, they're all just going to give us errors. Okay, well that is the lesson for today. Here's your fun for today. Maybe try a couple of the simpler questions and then bring the rest to class to work on in the classroom. So thank you for your attention, and we'll see you in class.